Добре. Предлагам да започваме. Радвам се, че всички сте на линия, толкова хора виждаме в нашите уебинари. Това е една инициатива, която HiCat стартира преди, грубо казано, 2 месеца с по-интензивно използване на новите медии, които така, от една страна поради ситуацията, която се беше получила тогава, от друга страна обаче явно имало някаква нужда за подобно такава технологична обмяна на информация. Създадохме. Моето име е Алеко Юмджиян. Аз съм от фирма HiCat Infotech. Тази инициатива, за която казвам, се нарича, или ние наричаме Дигитална академия HiCat. В рамките на тази Дигитална академия HiCat ще се опитаме, но и го правим, мисля, че с всеки път по-успешно и по-успешно. Мисля, че ще се убедите в това, след като видите и днешната презентация на доктор Бодуроглу, който е от фирма ОДЕЛО България. Ще се убедите, че темите са изключително интересни и с тях се опитваме да създадем една платформа за комуникация, за обмяна на опит, на нови модерни технологии. Едновременно с това тази Дигитална академия, както наричаме нашата инициатива Дигитална академия HiCat, се опитва да заздрави и да засили връзките с университетите, техническите учебни заведения, така че на младите хора инженерната професия да стане по-интересна, за тях да стане по-интересна, по-привлекателна, да успеем да събудим интерес на много повече млади хора въобще към инженерните професии и съответно да мотивираме тези, които завършват, да намерят своето поприще в компании, които предлагат интересни инженерни начинания и нека да ги кажем предизвикателства. В рамките на тази академия правим различни неща. Каним високотехнологични компании, това е днешния ден, където сме поканили фирма ОДЕЛО, която тя е една от доста интересните компании, които преди няколко години стъпиха в България, не само с производствена дейност, но и с инженерен офис или с развоен офис. От друга страна правим и уебинари, такива онлайн сесии с университети. Вчера беше представянето на Техническия университет в Пловдив, миналата седмица беше на Техническия колеж в Ямбол. Планираме и за предстоящите седмици до края на студентската кампания да дадем шанс на различни университети и технически колежи да представят своята дейност, така че да събудим точно да постигнем този ефект на обмяна на информация. Фирмите да показват какво предлагат като възможности от една страна, като опции, да се покажат интересни иновативни проекти и от друга страна университетите да покажат какво подготвят и какви интересни програми предлагат за младите хора. Много бърз ще бъда и много кратък по отношение на HiCat. Възможно някои от вас да не познават нашата компания, което е съвсем нормално. Нашата компания е инженерингова компания. Нашите дейности са съсредоточени главно в инженерното проектиране и внедряването на виртуални технологии за индустрията. Какво значи това? Ние сме основен партньор и единствен за България на един високотехнологичен концерн, който се нарича Dassault Systems. Фирмата Dassault Systems е доста позната в света на инженерите, тъй като те разработват от много години системи. Много накратко, това ще бъде единствения слайд, тъй като искам да запазя максимално ценно време за презентацията, която предстои, тъй като тя е фактически това, върху което ще се съсредоточим. Като нашата фирма HiCat Infotech представи или представлява компанията Dassault Systems в България и внедряваме техните решения, като от една страна ги внедряваме, от друга страна ги поддържаме. водим обучения, консултации и правим точно това, което виждате и в момента. Опитваме се да създаваме интензивни връзки между бизнеса и образованието. Няма да навлизам в повече подробности. Ще кажа по отношение на презентацията днес. Бих искал да представя нашия лектор днес, когото успяхме да мотивираме и да спечелим, да си отдели от своето време, да направи презентацията главно за вас и да покаже някои новости и интересни, нека да ги кажем, фасети в сферата на автомобилното осветление и по-точно как се разработва автомобилното осветление днес. Какво значи автомобилно осветление? Това са всички предни и задни, предни фарове и задни стопове, които днес представляват една изключително комплексна, сложна система, в която може да намерите механика, термодинамика, осветление и оптика, електричество, електроника, дори вече софтуер и всичко това събрано в много малко място и ограничено от изискванията на дизайнерите и тези, които създават стайлинга на автомобилите. Така че доктор Бодуроглу ще ви разкаже малко повече от кухнята и се надявам да бъде много интересно за вас. Как ще протекат нещата? Презентацията ще бъде на английски език, като ако имате някакви въпроси, просто стопирайте или ми пратете едно съобщение. Ако искате, може да го зададете въпроса накрая, или пък ако не се чувствате сигурни евентуално в думите, мога аз да преведа това на английски език. Така че стартираме. So, Sercan, we are starting. I will give you the presentation, and I'm happy that now you are managing to be on the stage. So okay. I'm giving you the presentation. I'm making you as a presenter. So now here we go.
Okay, I will share my screen now. I think it's visible, my screen.
Yes, perfect. You're on the stage and you're online.
Okay, first of all, Alec, personally on you, in behalf of HiCat, I would like to thank to give this kind of opportunity to us to share our experience with the new interesting contacts. We are happy to share our experiences because it gives us opportunity to increase the knowledge each other. So technical information is always valuable for us. We want to share it. So in this today webinar, we will go through from the beginning to the end of what we are doing. I would like to give first information firstly about our group, and later we will speak about automated exterior lighting. What does it mean? And next step, how to develop, we will discuss. And additionally, one page I want to mention productivity in design, especially for CAD design. I want to mention something more about it because of HiCat, because of Katya is one of the our major software which we use during design. And the end, I want to make a link between design and production, and it will be the conclusion of our presentation. So, ОДЕЛО Group. What is ОДЕЛО Group? ОДЕЛО Group is an automotive exterior lighting company, international located. We have two headquarters. The customer focus headquarters in Stuttgart, Germany, which means director of R&D, the sales director, project management director. Customer relevant disciplines are managed in Stuttgart. The second location is headquarters in Turkey. It's operation and finance. Operation means for us the production facilities, process lines, quality management, tool shop, which links to operational output is managed by Turkey. This is the global footprint of our company. We have different locations in the world for the production, also for R&D. For production, we have China, Slovenia, Germany, Turkey, we have also Mexico one small warehouse, not fully production, but completing some assembly lines. Also, most of our people who attend this webinar knows that we are in Bulgaria for the next level investment in Plovdiv for production plant. For R&D, his main center is in Stuttgart. The second R&D location in Turkey, Bursa, and also we are in Bulgaria, Sofia, as third R&D center. In Sofia, we are quite new, almost officially 1 year we are here. So we are quite new in the organization for R&D point of view. Here is some pictures from our survey in Bulgaria. So it starts from startups, factory buildings, openings in the R&D, also openings of factory. So now its factory is almost going on for the production for service parts, but also new Daimler lamp will be start in civil production soon in following months. Some key products from our portfolio. We mostly work with well-known OEMs in Europe, so especially German OEMs by BMW, Volkswagen, Audi, Daimler, SUV. We do design. Also, we have headlamps in our production portfolio in Turkey mostly. So we are working for Ford, Daimler, also Toyota. If we speak about our innovation way while the history of our company, we have some innovation portfolio in our company which makes some breakthrough in the design of lighting. From the first, we can say that first LED chimsel in Europe, we do it in ОДЕЛО group. Chimsel means the high-mounted stop lamp which is located in the back rear of the car. So first, turn indicator integration rear lamp is also one of our designers' idea in Stuttgart. Later on, side look LED is also one of the most important action in the sector because we started to use as ОДЕЛО 90% tinted LEDs in our group. At that time, ОДЕЛО group has also belonging its own LED production factory in Germany. But later on, we strategically moved out from this sector. We make a strategic engagement with awesome LEDs. We use their LEDs and we sold our LED factory. Going on from the innovation levels, we continue to make some interesting studies in the lighting sector, but the last level which we proud is the first OLED-based tail lamp in the market. Actually, maybe you already know in the markets, OLEDs becomes more and more interesting designs, and with BMW MG GTS version, we were the first company which make a civil design for OLED in the lighting sector. These are our key customers, as I also mentioned in the previous pages. We mostly work with all well-known OEM in Europe and also in the other regions. Let's speak about more technical now. It's the first stages. I just fast jump, not to go so deeper about the company, but now I think it's more interesting session starts. Let's speak about exterior lighting. What is exterior lighting? Actually, it's simple lighting, which makes us to see the road, to be seen by the others, and to get contact with others, which means contact when you turn left, when you turn right, you make your signal active and you say, I am turning left, I'm turning right. When you slow down, you put your foot to the brake pedal and you make there's a stop function activation. So it's make a connection between the other drivers. From this perspective, we describe as lighting is one of the sense of drivers. It's really important sense of drivers. Functionality is important. But on the other hand, just for functionality is not enough because lighting is really lighting became one of the major stylistic part of the car. Just look in the picture here. When we look from the past to the here, you see how evolution of sightlines can go back. In the last picture, actually, I really like this. When I compare the previous one, we know now without looking the brand logo on the car, we can remember the car from their lightnings. When you see the car, you say that it's BMW, it's coming behind back. For example, just assume that you are driving in the street and one car behind is coming like that with angrily looking lightning in front of you are in back of you, and you're a little bit afraid. You want to give the road to the other driver to pass you, or the other car comes like that with old model Volkswagen without anything sensing. There's no stylistic input. There's just car. It's completely make different sense in the driver side. So it's really important for the sensing driving, for the stylistic input is one of the key parts for the exterior stylistic. But yes, at the end, this is stylistic part, indispensable stylistic part, but the main task is at the end is lightning. So to make a lightning, we should be under control in some legal regulations. And doing this main task, of course, lightning performance is the most important for us to expectations. Let's speak about now how to develop. So this is the part which will go all over the world. It will become a car which will be under desert maybe, or it will be in mud or vibration, rain, dust. So basically, what is the extreme conditions will be in the world, it must be survived by our lightning part. So this is the first input for us to be enough strong under these extreme conditions. This is input. This kind of inputs comes from customer depending of the market. This kind of inputs comes from customer depending of the expectation of also segment. For example, we have different expected from Volkswagen Passat with Volkswagen T-Roc, for example. They are different markets, they have different expectations. If you sell the car to you want to sell the car also to the desert area, you increase your expectation for the temperature behaviors. So this can vary. The expectation can be very different ways. But at the end, there's always main headlines from this, which means they always ask about temperature, they always ask about rain, they always ask about dust. This is something which we cannot avoid. This is the first expectation, which means the life cycle you should survive. But the other thing is also stylistic, which we mentioned. Style. This is one example which I put in the picture. It's 2009 design Volkswagen Renault Twingo. It's quite simple lamp. It's quite simple lamp. We have only 3 bulbs with one lens and one bezel. But even with this simple lamp, you see how it's changing during the design. It's changing the style, it's changing everything step by step. So these steps, we go step by step to expectation of customer stylistic, also considering the production, also considering the input of the tooling, production facilities, everything should be concentrated during the design to make a final level of the part. This is the cycle of our development. So let's step by step go to this page. First is stylistic input. This comes from customer, already described. Part design is one of the major things which we have to do. It's a framework. Optical design, we have to control the light. Thermal management, under this control, the light sources always create some thermal, which we have to also control this thermal management. Structural management or structural engineering, our lamp has to survive this under extreme conditions. Mold engineering, this is also one of the important for us because our parts is mostly produced by plastics. Plastic means tooling. Tooling means injection, and this is quite sensitive to make a good production. So we have to care about this during design. Test, material engineering, and these are also, we have to know what kind of expectation from customer. And sure, electronic is one of the major in the recent years because nowadays the lamps going more and more and more for everybody, or for every OEM's electrical level. Prototyping is the last level before design goes to the production, because we have to also control in prototype what's going on. How is it working? Is it good enough, or we should change something? It's not easy just to check it from web, from application, from CAD. We should also touch it physically. Certification is before production is needed to sell it officially, and the production is the last level to go manufacturing. This is the loop for us to development. Let's go a little bit deeper in the disciplines. Optical design, light is an energy particle or photon, which we say which is invisible wavelength for us. At the end, photon is a particle which moves in different wavelengths from minus to the plus infinity. in each wavelengths have different energy level. What we look for, only we look for the visible wavelength, which is really tight, narrow zone. If you consider all wavelengths, it's only between 700 nanometer to 400 nanometer around. Even this area, we have different colors instead of one full package. So we actually care about this area for the photon. The light sources which you create is quite well known with the most of the people. For the automotive, we use first incandescent bulb, and this bulb for 100 years is produced. This is basically produced the light with radiative energy approach. So actually, when you heat up the tungsten filament, this creates a really high level radiation energy, and this radiation energy is separated also a little bit invisible area. So you create a light from the radiation energy. But unless even you create a light from radiation energy, you have really high portion of the energy, it still remains in the infrared zone. So this is the really inefficiency of the bulb. We try to create some light with the bulb. You create maybe 5% of the light in the visible area, but 90% is invisible or infrared, which means as a trouble for temperature. We have to control this temperature. It's a loss of energy. The other type of bulb is xenon bulb. Is quite luxury bulb in the past. It was used for high quality lamps, high quality expensive cars, but nowadays exchanged with LED. In xenon bulb, is electroluminescence system is working, so there's no direct radiative energy. It's using the chemically light output from the interior gas inside the bulb. Nowadays is most uses light sources LEDs, light emitting diodes. So the LED is extremely high performance when we compare the bulb, and because of this we have enough efficiency when we compare them, and light time is also extremely high when we compare the bulb. But there's one thing which is trouble for us in the LED. If the LED has under temperature, its performance is changing, which means if you have a bulb, whatever you have, the light output of the bulb is stable, but for LED is not stable. So in LED, temperature management is quite critical to have a good optical output of the lamp. So LED is good from the efficiency, but we have to control the temperature on the LED in behalf of to manage a good optical design. So this is one of the critical for us to check the LEDs. Optical design. When we speak about the light source, yes, now we created light from the bulb or even from the LED. Now, the main purpose for us to send the light where we need to send or where we want to send. From this perspective, the optical design has two main purposes in our lighting systems. First is to send the light to the legal requirements. At the end, light goes to the eye of the other driver, or light goes to the ground in front of you to illuminate the ground. So you have to send some light to the target which is needed to be illuminated. This is physically, there's an amount you have to send. But the other important things which I expressed already in the beginning, stylistic. Stylistic means the opposite side. We should now look to the light source itself, how it looks like. So now we are not looking anymore where light goes. Now we are looking to the light source itself. So it's most of a rear lamp. When we go to back side of the car, we have to also see a homogeneous light distribution or stylistic expectations of really fitting what they want. So there's, with these two main purposes, we have to manage light in physically. To manage light physically, of course, this limitation. All of us knows if there's a light, it could go to a material, which means it's transparent, or it could not go to a material, which means it's opaque. If it cannot go to material, there's two options. Some of the light could reflect back, some of light is absorbed by the material. So this is the first to manage light is reflection. If it's a mirror light, it's specular reflection. It's all the light goes in the same angle. Diffuse reflection means the light comes in one certain angle, but the leaving is completely random. So if there's a really rough surface, it goes like that. In real life, it's always in between. Sometimes we have to make a specular reflection as much as possible. Sometimes, because of in purpose, we make diffuse reflection to make homogeneous light diffusion. So this is the reflection style. Is simply we use mostly parabolic designs in the beginning, and later on we make a small updates in the optic surface. The other is internal reflection, which is also so critical for us to make design in last level expectation of the stylistic. Internal reflection means if we think about the light which goes through one transparent material, each transparency or each medium which has transparency has different refractive index. Depending on the refractive index ratio, the light has a critical angle which could make an internal reflection. I want to express this with the example. What is really I am liking to give this example. If we be in a natural area, and if there's a lake in that natural area, when we look at inside the lake, we will see the under the water. If there's a rock, we see it. If we look at perpendicular inside the water, but if we look a little bit far away, and if we sit down and if we look to the water with inclined angle, we will not see any more inside the water. We will see the reflection of the mountain onto the water surface. So this is the meaning that the critical angle, we already passed the critical angle. Now the surface of the water becomes a reflection for us. So we use this in our designs as internal reflection in the plastics. So we say light guide, and we send, or light bar, whatever we say, internal reflection. We send the light inside the plastic tube, and this light theoretically goes inside the tube in the direction of under critical angle. And sometimes, on some locations, we put prisms and we send the light out from this plastic tube just to make visible of the light. So here you see the screen. Here there's some examples for the light bars, light guides. And these light guides makes us quite easy to make different shape of designs. Here, this is one diameter lamp you see. It's a plastic completely around here, and we illuminate this plastic only with 2 LEDs in between. There's all shape with 2 LEDs. This is also another diameter A-class. This is BMW Light H design. It's 3D shape lightning, which I think this BMW E8 or E3, I don't remember the project, but this is 3D shape lightning with this internal reflection. And this is Volkswagen Touareg. Here we have one light guide all area, and we have one LED in the edge. When we have light and when we match the light with optically, at the end light source is produce some lights which we use it. And doing optical design, of course, we have some inefficiency which we cannot use off the light. But also from the energy point of view, we have also inefficiency in the beginning of the light, which means light source creating the light cannot create the light as 100% input of energy. There will be always some loss depending on light source. This loss energy is appearing in front of us as thermal, which means we have to control thermal in our lamp not to make trouble for our design. If we speak faster, what's the thermal? What is the heat transfer? So we have 3 modes in normally, everybody knows this. In thermal, we have conduction, convection, radiation. So conduction between solids, convection between solid and fluid, and depending on the force flow is maybe forced convection or natural convection. Also, radiation is without anything medium. We have a derivative light source. If we think about it, in our lamp, we have all 3 modes of the lightning designs, which we have to do design considering these lightning modes. So if we think about the bulb itself, produce light with filament, with tungsten filament, which creates full radiation energy. So some of the radiation energy goes to the visible area, which we say it light, but most of them is still invisible area, infrared area, which we have extremely radiative energy there. So we have to think about how we will manage to dissipate this radiative energy from the lamp without damaging our plastics. On the other hand, through the air inside the gas or around the air inside the lamp around the bulb, there is also air which flows internally, and it makes convective heat transfer. plastics or metals is also conductive. So these modes are all in our lamp, and we have to care about them, how to manage, how to dissipate light. What is the basic approach for our side? We should send the temperature in safe area. We should move this temperature to the safe area, which we have to avoid this kind of defects on the plastic or the light source defects. From LED point of view, it's quite different than the bulb, because LED itself is not creating radiative energy so much. It's actually a negligible level. But in LED, it's mostly produced conductive energy, which goes to the electrical board. And in electrical board, we try to manage this conductive energy, first using, again, conduction through the board, which we make a layout design, trying to make optimized layout design to increase the temperature distribution in the board. And of course, when we increase the temperature in the board, it's contact with air. We should think about also convective heat transfer during the board. Electrical design. LED light source, which is quite new, is used maybe 15 or 20 years more in the lighting, is brings the necessity of electrical design and usage. Its simplest definition. Electrical board design is handled to have the necessary functionality with the geometrical limitation, of course, considering thermal dissipation on the lamp. So we have to make a design with electrically, you have to fulfill the functionality, you have to fulfill the regular thermal requirements of limited geometry. This is first input. Electrical brings us much more functionality actually. In the bulb, you have one bulb and you can switch on off the bulb from the car. But just imagine that if we have many LEDs in the lamp, and we have also enough intelligent possibility to manage these LEDs in different ways. So this gives us functionally flexibility. We can play with the light sources. So electronic design is giving us freedom to make different functionalities, which becomes step forward for software usage. But the other important topic for electronic design is actually electromagnetic compatibility or electromagnetic emission is quite important for us, because just imagine that if you push your foot on the brake pedal, but your brake lamp doesn't work because your radio is switched on your car. Your radio affects your electrical board in the rear lamp, which blocks the light. It's possible actually. So from this perspective, it mustn't be like that. So from this perspective, we have to be careful. We have to be careful about how our EMC or how our EMI complements will be in design. This is one of the major important things of electrical design. As I said, electrical brings us functionality. When you see the movie in the edge, the corner of the page, this is Volkswagen ID3 electrical vehicle. Maybe you already see it in the news. It's approximately 6 months before it's introduced in the Volkswagen. This is the new status of Volkswagen electrical vehicle, which we designed view lamp. In this view lamp, we have different animations. The animations we manage with different softwares. To make software, we need some microcontrollers, and microcontrollers managing different LED sources in different perspectives. When we enter the software, it quite brings much more complexity, because now you have to be also sure that software should be safe enough to fulfill the legal requirements. Because just before, when we use only simple electronic, there was one single lamp connected to the single car, and the car sends some electrical connection to the lamp and its activated function. But now, if we use software, which means lamp takes some software inputs from car and to think about what it is this, and I have to activate which function. In this perspective, you have to be sure that your function is right. Just assume that you make a left turn indicator signature, but your car will make right turn indicator instead of going right. It's possible, and it's a big trouble. I gave the example honestly because we have the same situation in this project. It's quite interesting. In Volkswagen side, it's normal for all OEMs. They introduce the prototype car to the CO for the first view and to get the last approval. So it's a special time for them to introduce in their internal CO. So we sent the lamp to the Volkswagen, and they equipped the lamp. They equipped the lamp into the prototype car to show this CO. Later on, they recognized that the turn indicators are working in wrong direction. It was quite interesting story for us. They called us. They said, "Okay, turn indicators work wrong direction because we make left, but it works right." Later on, we recognized there's a really simple bug in the software, which is quite trouble at that time because we have to fix it soon because before going to CO. So we fix it fastly. We put the new lamp into our luggage with the flight. We go direct to the Wolfsburg to change the lamp just before CO arrives to the introduction. So it's quite interesting time for us to even this is possible to show is it have different bugs in the software. If we have software, I said this could be happen trouble, so we have to be sure that the lamp will survive in extreme trouble positions to software. So it pushes us to use functional safety. It pushes us to use ASPACE approach during design, which is also next level expectation during design of exterior lighting. And mechanical design. This is something. It's maybe the most conventional design facility during the lamp because it's always there mechanical. Even when you make a design 1950s, maybe you make a metal, you make a glass design, but at then you make a mechanical design. So mechanical design is also from the beginning always with us, and it's the framework of design. You are making a mechanical structure which is holding all the parts. This is also one of the major important facility for us to combine all the parts in between in the proper way. And mechanical design of the lamp is completely always from scratch we start because of course we have structures, clippings, screws, but always with the new design, always with the new style, you have to redo, restyle, we check how to make mounting, how to put the parts, how to mount in the production. It's always start from zero for each design. So when we make a development, also I want to go more deeper what we should do in development, because development at the end we see that it's different combination of disciplines. But when you make a combination of disciplines, it seems also there are some additional problems between disciplines. Actually, it's reality. This example which I put here, I also really like to share with everybody because it looks like exactly in the picture. We describe development as a ball in the between all disciplines, and it's connected with chains to all disciplines. At the end, this ball in the middle is under static balance between forces which come from different disciplines. Who pull much, the ball comes closer to that, but at then it's balanced. When we look from this perspective, how much you pull, you go away from the other disciplines. And this is absolutely the same in the design. Who wants something is always negative for the other one. For example, optics wants maybe larger area in the plastic, but this is impossible for tooling. Mechanical wants to make a screw in the middle of the plastic, but optics says no, you cannot put the screw because it's visible area. Thermal says I really want 1 meter square PCB area, but electron says no, you cannot make because I don't have this area for the electron bolts. It's always like that. So there must be a balance between them, and this is actually pure design, the strategy of design to make a balance. And doing design, there are always inputs, outputs between disciplines. I mean, inside disciplines, there are always inputs and outputs. I also give example that there are also external inputs and outputs, which comes from customer, which comes from production, which comes from car body, etc. So from this input-output management, there must be some productivity to make it easy update of our design. Otherwise, it will be hell. It will be mess. just imagine that there are many inputs, but you cannot process them in time, and you will make a serial connection, all of them, and you wait step by step to solve them. It's impossible. You have to be really productive to think about the inputs to make an output, and all the boundary conditions during the design is also moving. You cannot wait to finalize the optic design, but optic design cannot wait to finalize the mechanical design because they have to move together. So that must be a productive. To go on a little bit more in productivity in design, I want to go a little bit CAD modeling because of also this today's organization by HiCAD is CAD DLF. So let's speak about CAD a little bit. In CAD modeling, the structure of the tree is quite important for the productivity. Just consider for the mechanical design, we have to be in line with car body. So car body will come some updates. Optical surface will come with some updates. Stylistic will be some updates. Mechanical mounting concept will be some updates because we have to think how to mount. Later, maybe we change it. Also, production will make some updates. Just think, you are sitting in your table, and every time there are some new inputs to your site. What should you do? Should you wait just to stop them, or you should do really fast response for each update? From this perspective, our CAD structure really must be enough mature level to make updates in right purpose time. This is the important for parametric. I want to show two examples in parametric view. So this is one design. Now we are designing for Daimler. This is a reflector which makes tail function with indirect reflection. And actually, in thermal simulations, we use finite element model. It's as common CFD modeling. In this finite element models, you mesh the structures in the thinner parts, and this mesh is one of the beginning of the simulation, and it's really important for the accurate simulation. In LED modeling, radiative energy is not so important, as I said, is negligible. That's why this really thin optical surfaces is not so needed in the simulation. If we can remove them, it will be really best for thermal guy because they really don't need these small optics elements. It will not affect their results. That's why optical guys request colleges, give me a thermal data without optical surfaces. Thermal guys request to mechanical design without optical surface data. If the optical guy, if the mechanical guy can remove them easily from the data, it's best for them. Just as visible in the picture, in the video, he clicked some links and he makes some updates cycle and just reflective without optic surfaces. It makes easy movable for them in just one click. Otherwise, let's think you try to move them step by step. Somehow you use maybe some generative shape design, maybe you use remove surface from the path design. It will be hell to remove all the surface. But if you build your structure in behalf of to manage this update in future, it's one click for you. This example, what I want to give you here is on productivity of CAD design. Another example here is optical surface. So again, optical surface. We have many optical surfaces, and optical design is never-ending story, extremely never-ending. Even in Toolgo, for us, Toolgo means the start of tooling production, which means design, finishing of design production. Even for Toolgo, if I ask my optical departments, I say, I want to give you 2 more weeks. Do you want to use them? They will say, yes, we want to use, because they will know finish. It's always, you cannot catch 100. Always you are in 90, 93, 98. Whenever you time, you continue improvement. So from this perspective, of course, in the legal level, we have to keep in a certain level. But from this perspective, optics are always updating for next level. To integrate these optic surfaces to our data, we have to find the best way to make easy update. Just imagine that you make a housing with reflective surfaces. Optic surfaces given to you 1 week ago. You spent 1 week to import these surfaces to your housing. You built a really solid data. It's really perfect, visible. Everything's good. When you finish data, optic comes to you. I make 1 more update. I want to use this surface. Can you adapt this? And you will be get crazy. Okay, I just finished this now. Why you did again? You will be get crazy if you are not prepared enough. That's the purpose. We should be create a really right modeling in the CAD to make an easy update in the CAD modeling with new inputs. Here in the picture, you see the just replace surface is working on our optical surfaces. When you make a replace surface, it automatically updates our optical surface in the CAD modeling. This is quite a good example to see what's needed to make a productive CAD design. Of course, to make this strategy, you have to build a really good structure of the CAD modeling to make it easy update. Otherwise, it will not update. You will see some troubles. You have to fix the file. Maybe if you use some sweep, it will not make a sweep. It's something trouble. So you should make a structure with good level to make an update easily. How to link between design and production. This is also one of the important link for the production because most of the production guys always blame R&D. It's impossible to close their mouth because they are looking from production facility. They don't know what we are dealing here in design because they don't know what inputs we have, what kind of troubles we are doing. They just know how they produce because this is logic for them. It's normal. And then they will produce this lamp for 4 years, for 3 years. And in this production, is only you don't see what they are doing. They are going live with this lamp to produce. From this perspective, we also really have to be sensitive in production. What our lamps is mostly thermoplastic materials, which means injection. Injection of the materials is built in tooling. And from this perspective, tooling and injection, our materials, our design must be feasible doing the civil design or doing the civil production of the part. Actually, I have many experiences in the production facilities. For example, when you make a really limited design in the production, in the tool, each week you have to make a maintenance on the tool because of this area. Tool has always trouble. And the production quality is reduced and scrap ratio increased. And this is always a hell production for whole life. But if you make a stable design, which means the tool is working properly, injection is working properly, everything goes properly. Of course, always there are some troubles. There must be some troubles because why we are here. Engineers here to solve the troubles. But the basic idea is, of course, to make it as much as less troubled design for the future. Let's speak about also mounting concept. Depending on the complexity, of course, our concept is changing. Here is the picture you see in the screen is the Volkswagen Touareg lamp. And each mounting concept must be also feasible doing handling the production and assembly line. And then these are produced in production, as I said. Let's consider only about clippings. Give simple example. Here in the picture, we have using different kind of clippings to mount this optical element to bezel and to carrier between PCB. We are using also sandwich modeling, sandwich squeezing between PCB and the optical element. So there's quite complex area with clipping. All clippings must connect in purpose, in the target here. And just think about the surface clipping. You see the difference between these two surfaces. Actually, the pitch of the clipping is the same, just the angle of the surface is different. It's simple to see from this picture. If you have a more inclined surface, it needs less force to clip it. This is more needing more force to clip it. So it's easy to clip. Just for this surface. In CATIA, to make a draft in this surface is 1 second. Just 1 second. You choose the surface, you make an angle, that's all. Let's think what this affect. If there's a 4 clipping on the part, if we have 50 lamps per hour of manufacturing, if we work 3 shifts with 3 hours, 3 years for all production with 300 working days approximately, the final output is 4 million clippings for whole life. To make a 1 second click on the CATIA, it will affect 4 million clippings on the whole life. Actually, this is really simple example, which just to make a map in the attendees imagination. It's not the real case. Of course, we have standards for the clippings, but just to show what is affecting. Just for one surface, it could affect for all life production. So designer must know. It will be really important for production. From production point of view, of course, we have many different production facilities which we have to take care about it. Injection, tooling, aluminum coating, assembly, welding, tool maintenance, quality controls, everything should be under control. And sure, as designers, we cannot know everything. If we know everything, why we need the other engineers in the production line? From this perspective, we have to also think how to merge this kind of knowledge into our design. First, prototyping is one of the critical steps for us to check what we are doing. Yes, I really appreciate we are using softwares, we are using complex softwares for optics, electronics, mechanics, but at the end, this is physical part which we have to touch by our hands. In CATIA, you put one clip. I know many designers, when they get the prototype in their hand, they say, oh, this is clipping so small. I was not thinking as it's small as like that. Because in the CATIA, you zoom it. You can zoom and you don't feel it's small. From this perspective, mechanical mounting with the prototype is important. We check it oftenly. Also, optical element, optical prototype. This is an optical prototype in the picture here, Volkswagen Touareg. Actually, this optical prototype is one of the major customer milestones. We go to customer, we speak about the light design on optical prototypes. And this is one of the major input in the design. On the other hand, yes, this is two prototyping facilities we deal for the design. As I said, as designers, we cannot be the expert for all knowledge. So we have to make a continuous and sustainable knowledge transfer is in the key point for us. So how do it? Of course, we are not discovering the world from zero. We are following the main automotive structures. It's as well known. So we use lessons learned, design ephemera, high quality data. Design review meetings is also one of the major things, because design review meetings, the people who will deal with this project, they make comment on your design, and from production, from tooling, even from process, they make comments on your design. Prototyping is important. Reflection is also one thing we name. It's Toyota name. Reflection is quality reflections. You follow up your quality topics for whole life of the lamp, and you make some reflections to design. It's a system you put in reflection, and you check this reflection for future designs. Checklist and design standards. Design standards is one of the easy example which looks linked to clipping also. For example, we don't want every designer to do clipping from zero. If we know that some of the clippings are well produced, well equipped with production, and is compatible with the needs, we make the standard. So we have a standard map. We choose as much as standards design, doing standards structure, doing them, but please don't mix the standards with to make a all standard design. Actually, our designs always unique. We have to think always from zero what we have to mount, how the optic concept will be done. But doing mounting, for example, you should use the same screw. Maybe screw location will not be in the same position, but you don't make always different screws, for example. This is the basic approach for design standards. At the end, all these activities are increasing our design quality, decreasing the inefficiency and over efforts doing validation, process, legal approvals, and several production quality is also increased with these activities. So this is really important to reflect design and production each other. This is the last page of my presentation, and this is a key message from our side. We say that, okay, basically design looks like cooking a meal. How much effort is spent doing the cooking, this makes as much as delicious meal which we will have in our table. So this is the key for us to make enough effort to make a good meal in our table. Thanks for your listening. Thanks to everybody for attending this webinar conference. Actually, it's quite interesting experience for me, because I get used to have this kind of presentations face to face, and I really like to touch the people, eye contact during the presentation. And because of these current conditions, yes, everybody knows Corona, COVID-19, we use this webinar, and it's also interesting experience for me to be online presentation. I hope every attendees have some input from our presentation, maybe some also good information catch for his personal life, and I hope we will continue this exchanging information each other. Thanks to everybody.
Thank you, Sercan, for the always. I have to say that your presentations, because I have visited your physical presentations, and I can say that your online presentation is almost as good as the real one, and I hope that everybody could listen and, as you said, to take something small, maybe even very small piece for him, for his work, for his daily life as a designer or engineer, as an idea and or as an information. Благодаря на всички за участието, че ви отнехме така, може би, този един час и този един час да е бил полезен за вас. Мисля, че аз лично всеки път, въпреки че съм слушал и други презентации на Серcan Boduroglu, всеки път намирам нещо ново, интересно дори за себе си от неговите представения. И той е човек от практиката с много широк опит, но и винаги готов да имплементира, да внедри нови технологии, нови методики на работа. И е много интересно човек да получи наживо информация от него, защото той даде накрая пример с една кухня, наистина и ние успяхме да видим от кухнята как се разработват днес, и то не само в София, може би почти навсякъде на света, по какви методи и какви процеси се разработват автомобилните осветления. Благодаря на всички за участието ви. Надявам се да разпространите тази информация и до други колеги за нашите семинари, за нашите тези, нека да ги наречем технологични беседи, и да се чуем и видим в нашите следващи такива. Благодаря на всички. Sercan, thank you very much from our side.
Thank you very much, Alec.
Presentation.
Thanks also to you, Alec. Thanks for this opportunity. As we met before with you several times, I really like to continue this kind of information exchange because it also motivates us as companies. I know, as I am in technical guy, I'm engineer, I know this kind of exchanges is quite interesting for everybody. Even you are working in the sector or not, but you know what they are doing. I know many people who met with us, they said, I was not thinking that rear lamp or lighting is just such kind of design, because you don't know it. It's always good to open your eyes to check what's going on around the sector, and I believe that automotive sector is a good input for the Bulgarian area, and we all together have to increase this information exchange to increase this effectiveness in this region. So thanks for this opportunity again. Hope to continue this kind of events for future.
Thank you very much. Also that you are supporting also our events, and maybe also as a signal to everybody, I will tell this in Bulgarian. Sorry, I see some people are speaking maybe only English. I don't know. I'm just looking on the names.
I cannot see who attendees.
Okay. I see Alberto. I think we spoke once on the phone, and I would just say a few words in Bulgarian. Ако желаете и смятате, че и вие сте бихте могли да покажете и разкажете за някакъв интересен проект по някаква интересна тема, пишете ни и ще направим подобен семинар и по темата, която предложите вие. Така че това е една открита, абсолютно безплатна инициатива. Безплатна е естествено за всички. Смятаме, че всеки трябва да покаже това, което може и това, което Серджан разказа, под някаква форма и да помогнем на България и нейната индустриализация, да помогнем и повече млади хора да се мотивират да работят като инженери в бъдеще, защото в края на краищата те са най-важната част, човешкия фактор. Добре, благодаря на всички, желая на всички приятен следобед и разбира се приятна събота неделя. Have a nice weekend to everybody who is not speaking Bulgarian and didn't understood the last two sentences. I wish you to join our next activities. Stay tuned and just look maybe and follow our news in LinkedIn or Facebook. I don't know how you have got the information. We are publishing the information on our website, on our LinkedIn site, on our Facebook site. So these are the possible communication channels what we are using at the moment. Okay, thank you. Благодаря на всички и приятен следобед.
Thank you again. Have a nice weekend. Bye. Ciao.
Thank you, Serjan. Thank you very much.